Okay, this is the P3 paper from January 2023. It's question number 5, and this is chapter 4, trig addition formulae. When we're looking at this, we can see we've got a trig proof involving double angle formulae, and we've got solving trig equations. So let's make a start. Part A then says that we've got cot squared minus tan squared, and we're trying to prove it's identical to 4 cots 2x cosec 2x. Now, one of the first things I'm always asked is, well, how do you know where to get started? And the simple answer is, I don't normally. I think you could start with the right-hand side and get to the left-hand side. I'm not going to try that. I'm going to try the left-hand side and see if I can make it the right-hand side. Simply because if I think of cot, I know that cot is cos squared over sine squared, or the cot squared is, and I know that tan is sine squared over cos squared, and that just looks like a really promising way to get started. I know what the next stage is going to be, multiply, multiply, and multiply the bottom two together. So I might go 3 or 4 steps through this, think it's not getting anywhere, and then go start with the right-hand side. But let's keep going with this left-hand side. So if I do subtract those two fractions, cos squared times cos squared gives me cos to the 4. Sine squared times sine squared gives me sine to the 4. All over sine squared cos squared. And then this is where actually doing a lot of hard work and going through and doing a lot of these proofs really pays off. I've seen cos to the 4 minus sine to the 4 before in other proofs, and it's a difference of 2 squares. So cos to the 4 minus sine to the 4 is actually cos squared x minus sine squared x multiplied by cos squared x plus sine squared x. And again, if somebody said to me, yeah, but how do you know to do that? Simple answer is, I've seen it before. And because I've seen it before, it makes it that much easier for me to actually notice it there. And obviously, when I do that, what's really useful is that cos squared plus sine squared, cos squared plus sine squared is equal to 1. So again, it's been knowing my identities really well. So at this stage then being able to cancel that out and get cos squared x minus sine squared x all over sine squared cos squared. And then actually don't forget to have a look at what we're trying to get the answer to. The answer that I'm trying to get it to is cot 2x cosec 2x, which again, sounds really confusing, but at least I can see there's double angles in there. And if I can see there's double angles in there, then the double angles I know really well are cos 2x and sine 2x. And in fact, actually looking at that top numerator is cos 2x. Cos 2x is cos squared minus sine squared, it's 1 minus 2 sine squared, and it's 2 cos squared minus 1. Now, I'm not reading that off any sort of formula sheet. They're in my head, and because they're in my head, it means I can spot at this stage in the middle of one of these questions that cos squared minus sine squared is cos 2x. What I can also spot is that actually sine squared x cos squared x is sine x cos x squared. Why would you be interested in sine x cos x? Because sine 2x, which is one that I know really, really well because it doesn't even have any variations, it's just 2 sine x cos x. Well, if that's true, then sine x cos x is half sine 2x. So now I get really excited because I'm really close to what I might think my answer might be here. So I've got cos 2x all divided by, and I think that this is a half sine 2x all squared. And now I bet I'm not too far away from actually getting it to be cot and cosec and the 4's in there. So just take my time. I'm excited, but I don't want to lose any steps here. This is cos 2x over 4, and I'm just going to put sine 2x, and then I'm going to put another sine 2x there. Really weird way of writing sine squared 2x, but it's because I'm now going to be splitting this up into 2 different parts here. Okay, sorry, that's a quarter there, isn't it? That's a quarter there, which will then become 4. 1 over a quarter is a 4, and I've got cos 2x over sine 2x. Well, that is cot 2x and I've got 1 over sine 2x, and that is cosec x. So I'm now just 1 line away from my answer. It's equal to 4 cot 2x cosec 2x, and just to show off at the end, equals the right-hand side. So as we went down through that proof there, starting off at the left-hand side and ending up at the right-hand side, that will fill out really quite nicely. Part B then is solving an equation. Keep an eye on what the limits are there between minus pi over 2 and pi over 2. So first of all, that tells me to work in radians. And from my knowledge, I'm not going to spend too much time going through P1 and P2 trig when we're doing the answer to this question. But between minus 90 and 90, or between minus pi over 2 and pi over 2, there won't be too many answers. When I get to my stage where I'm looking at my answers, that should be quite quick for doing that part. So it says, hence solve this, and what it really means then is I'm not going to have 4 cot 2 theta cosec 2 theta. I'm going to have cot squared minus tan squared there. So let's just get the question written down and try and make a start to it. So part B, I got 4 cot 2 theta cosec 2 theta is equal to 2 tan squared theta, but then the 4 cot 2 theta cosec theta, that's going to be cot squared minus tan squared. So I've got cot squared minus tan squared is equal to 2 tan squared. And then again, as I said to you previously, this is all about hard work and just looking at these. I know cot squared is 1 over tan squared here, so I'm going to have 1 over tan squared minus tan squared is equal to 2 tan squared, and that's not going to take me too long to actually go through and work it out. If I multiply everything by tan squared here to get rid of the fraction, 1 minus tan to the 4 is equal to 2 tan to the 4. Take that tan to the 4 over, I'm going to get 3 tan to the 4 is equal to 1, so I'm going to get tan to the 4 theta is equal to 1/3, which means tan theta is going to be the 4th root of 1/3, or 1/3 to the power of 1/4 when we're doing it. I'll get a plus and minus answer for that, so I get that tan theta works out to be, I've already done this one, so it works out to be plus or minus 0.7598, which is then going to give me theta, having 2 different answers between pi over 2 and minus pi over 2, and they're 0.65 and minus 0.65. I'm not spending any time going through that last part because it's not P3 work really, and you can always look back at other questions to have a look at that. Okay, hopefully that all makes sense to you.